Next, we have another algorithm that is used for sorting, that is called as the counting sort algorithm. Counting sort algorithm basically sorts an array by counting the number of, so it is a linear time algorithm basically. Linear, like the, it performs the task linearly. So what do we do in the counting sort algorithm basically? See, it is based on the counting of the numbers which we have. So we compute the frequency of each number that is there in the array, and then we take one more auxiliary array, that means the temporary array we take. And here in the counting sort we have to be careful that the size of the array that we have to take, the new auxiliary array that we are going to take, counting sort, uh, here you see this is the input array, right? So in the input array, what we have is 4228331, right? So that we have some numbers in the input array. So the first step in the counting sort is we find out the maximum value. See, this counting sort array, when we have to perform this algorithm, we first of all we need to have the range, right? So here you see the range is from 1 to 8, right? The maximum number is 8. So for this, you can say, in the working of counting sort array, sort algorithm, what we have to do is we have to take one auxiliary array, and the size of that auxiliary array will be equal to the maximum value of the array plus 1, right? Why we are taking this particular auxiliary array? So in the auxiliary array we are going to store the frequency of each element in the this particular given array. Like the frequency of 4 is 1, frequency of 2 is 2, frequency of 3 is 2, frequency of 8 is 1, and frequency of 1 is 1. Now when we are taking the range of this particular array, the numbers over here which are given to us in the array, which are supposed to be sorted, these numbers will be representing the index of the auxiliary array. Here you see, right? So this is the auxiliary array. We have taken its size 8 plus 1. So from 0 to 8, it becomes 9. Initially, we have assigned all the zeros to this particular array. Now, one by one, what we are going to do is, now in this particular auxiliary array, 0, 1, 2, 8, these index values, they represent the elements of the given array. So corresponding to each index, we will be writing its frequency, right? Let us say, like, if we are saying that 0 was not there in the array, so here you see, you can note down the numbers which are there. So we don't have 0 over here, so that means its frequency is 0. We have 2, its frequency is 2. We have 1, its frequency is 1. So correspondingly, if you see this particular array, 0, so its frequency is 0. Number 1, its frequency is 1. Number 2, its frequency is 2. Number 3, its frequency was 2. And 4 and 8, their frequency was 1 in the given input array that we are supposed to sort, right? 5, 6, 7, their values are 0 because they are not there in the input array. Now, from this particular auxiliary array, now we are going to take the cumulative sum. So what we have done from the given, in the same array, first we have taken the frequency, and now we take the cumulative sum of this count of the array. So it helps in placing the, you can say, the values of the array at the appropriate positions in the sorted array. So here you can see 0, 0 plus 1 is 1, 1 plus 2. Here you can say this is 1. So 1 plus 2 is 3, then 3 plus 2 is 5. So here the values comes 1, 3, 5, 6, 6, 6, 6, 6, 7. So these are the values we are able to get. These are the cumulative sum of the elements from the previous step, right? So now what we are going to do, we are going to find out the index of each element of the original array in the count array, and after taking the cumulative sum, we place the element of all the index calculated as shown in the next slide. So what do we do? So here you can see, now we see the input array because it was representing the index value in the count array. So here we move on to, from the 4, the first value was 4, we move on to the index value 4. And what is the value at this? The cumulative sum was 6 over here, and we represent, so we subtract one value from here, 6 minus 1 is 5. So the index value for the new output array, now we are creating a sorted array using this. So at the index value 5, we place the value 4. right? So it is coming at its appropriate position. Similarly, let's say we take up the 2. From the 2, right, so we move on to the index value 2, right? So the index value 2 here, it is its value is 3. So we see 3 minus 1 is 2. So we move on to 2 and we place its value as 1. So this is how we are going to convert this unsorted array using the counting sort algorithm into the sorted array. So this is how. So after uh, placing each element to its correct position, we just decrease the count by 1, because we had increased the count by 1 in the very beginning, and finally we are from the by applying this technique we are able to sort the given array. So this is, here you see I is equal to size minus 1, while I greater than equal to 0. Output count array minus 1 is equal to array j, and count array j is equal to minus 1. So we just subtract its position and we are able to get that. So from the counting sort algorithm, if we convert this particular process in the form of the algorithm, we say we have a counting sort function which takes as input array and the size. So if max find the largest element in the array, that step we did, we found the largest element. Then we initialize the count array with all the zeros. The second step we did, for j is equal to 0 to size, find the total count of each unique element. We computed the frequency of each element and store the count at the jth index in the count array. That was the next step. After taking the auxiliary array, the auxiliary array was the values in the auxiliary array was taken as the frequency of all these elements. So in the next step, what do we do? For I is less than 1 to max, what do? We find the cumulative sum that we did in the auxiliary array. We found the cumulative sum and store it in its count in the array itself. And finally, from size to 1, we restore the element to array, decrease count of each element restored by 1. So the last step that we have seen. So finally, we are able to get the sorted array by applying the counting sort algorithm. So the time complexity of this is O n plus k, where n is the number of elements in the input array and k is the range of the input, because range plays an important role. Based on that range only, we are performing all the steps in the counting sort algorithms. So the time complexity is of the order of n plus k, and the auxiliary space which is required for this is also O n plus k, because we are creating an auxiliary. An extra array is required in order to sort the algorithm.